Hey everybody, it's Armin. Today we're doing a video on NC Miata fan systems. I'm planning on coming out with an NC fan upgrade, so I thought it would be a nice idea to do my due diligence and measure the differences between stock and my system. So first I'd like to explain how the stock system works. It's a 3-speed fan, and it runs just like this. So we have a stock fan here attached to a coil rad. This pin right here and that pin right there become a power and ground on setting 1. Setting 2, we maintain power and ground, and we add a second ground. And then on setting 3, both yellows become ground and both reds become power. And that's it. So what I've found is that my little power supply here at an 11 amps is enough to handle this on max setting, so we're going to be testing on maximum setting. I did a little bit of testing before the video here, and on a 12 volt setup, so I had it set for 12, fan speed 1 is about 5.4 amps, setting 2 was 6.6 amps, and setting 3 was 8.8 amps. So we're going to be doing the test at 12.7 volts because my test battery over here is at 12.7 volts, and the other fans that we're going to be testing are too much amp draw to use a power supply. We have to use my test battery over there. We'll explain that a little more when we get around to it. So for now, I've got my little test setup here. It's just a couple of pieces of wood holding up this coil rad. And what I've done is I've marked a grid of 2-inch squares all over the radiator. So what we're going to do is we're going to be using my little handheld anemometer, and we're going to measure airspeed at every one of these spots and record it down. So after I fill up the grid, we'll have the data, and then we'll be able to compare that data to several circumstances. First, we're going to do stock fan. Then we're going to do stock fan after I tape up and seal up all the edges to see if there's a measurable difference to actually sealing the fan up. Then I'll be able to tell you guys if it's worth sealing up your fans, because I go through the effort all the time, because on the engineering side of things, if you have an imperfect seal, then how do you know your fan's pulling from the front? But now we're going to measure how much. After that, we're going to test out my experimental setup and see just how much that pulls as well. I have a couple of fan options in the works, so we're going to see just how far we need to go with these other fan options to get a better result than stock. Just for transparency, I'm going to demonstrate that we're in a no air interference area. You can hear our big shop fan over there moving. So I'm going to go ahead and stop this guy. We'll sit it up against here. So as you see, no measurable movement. We're sitting at 0. So there's no air coming through this thing. So for further data, I went ahead and checked the amperages of the 3 speeds at 12 volts as well as at 12.7 volts. So the stock fan, speed 1 pulls 5.8 amps, speed 2 at 7.2, speed 3 at 9.5 amps. So 9.5 amps is our absolute max draw right now. And as I mentioned, we have our 2-inch grid here, and I'm just going to start measuring and write these down. Well, that concludes our first test. Now my arm's tired. So we have a high of what looks to be a little over 5. Let's see. I got a couple of spots that said 5 meters per second. We're measuring in meters per second. And the low was a 1.1 over in this far right bottom corner. So now I'm going to go ahead and seal this thing up best I can. We're going to repeat the test just to see if we get any improvements. Okay, I want to demonstrate what I've done. Got a lot of painter's tape on this thing. We taped it up as best as possible. I mean, this is probably more than any of you guys have done on your car to get better airflow, but we just want to see how much difference it makes. I also did weather strip around 3 of the edges, not the bottom one, because that one's pretty close to closed. So now we're going to see just how much of a difference this makes over just as is. All right, so we're set up and we're running with the fan once again on high speed. We have all this stuff sealed up. Let's start measuring again. All right, we now finished our second test here. Looks like our highest went up over 5, so we have a 5.1. We have a lot of numbers that seem like they're a lot higher, and then we have one that actually went lower. The bottom right corner was a 1.1 and went down to 0.9. But we'll go over this in the review after the end of all of the testing. So now we're going to switch out for one of my fan setups, and we're going to repeat the test. I just finished setting up my, my aftermarket fan setup, and I did it the same luxury of taping up the top and the bottom. The rest of it is actually sealed really well. So what I have here is I have a battery set up because this fan pulls a lot more than my power supply can put out. So I have this little guy, it's a little shunt, and what this does is this measures out our voltage, our current, and a couple other parameters that I'm not going to be using. But our main thing is, the reason I did my last test at 12.7 volts is because this battery shows at 12.7 volts. So in all fairness, the other one should be run at 12.7 volts. Now, we'll be able to test how much amperage this thing pulls once I plug it in, and I'll make note of that on the screen now. So now what we'll do is, I won't be doing any talking while this runs because it's a bit louder, but we're going to go ahead and plug it in and do the same test all over. Okay, so as you can hear, my noisy fan's running. What I've done is I've hooked my power supply up to the battery to try and keep it up on voltage, because when we kick the fan on, it kicked down to 12.15 volts. Now that I have the power supply hooked up with it, it's helping keep some of the voltage up. So we'll be doing a test somewhere between 12.3 and 12.5 volts, it looks like. But the fan is pulling close to 20 amps, which is significantly more than the other fan was. So let's do some measurements now. All right, so we got some pretty impressive numbers here. The highest was, I think we got an 8 in here somewhere. Well, we'll review the numbers here in just a little bit. So I'm back here at home with my assistant, of course, and we're just finishing entering up all of this information into a spreadsheet. So what I've done here, as I'll show on the screen, is I've put together all of the information from today's test. So first let's take a look at the stock NC fan. What I have here is just a simple gradient to show bright green is the highest value and dark red is the lowest value. Then of course I have max, minimum, and average airspeed across the whole grid. The axes of course are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's just the distance from left to right on the radiator, and then of course the left side is from top to bottom. It's exactly how you saw me take the test. So the total value is just sort of a comparator I'm using for this test. You really can't say that the total airflow is 260 meters per second for this, but it gives a nice comparator because we're comparing the exact same method of testing versus the next. So it gives us at least some means of comparison. That you could go by the average as well. The average is at least reasonable. But what you'll notice about this is the placement of the fan as well as the bias of where the fan pulls. So the fan is obviously biased a little bit towards the left side, so that is the passenger side of the car, and it doesn't seem to pull very much air towards the driver's side of the car. It's very low values over there. And also you'll notice it also seems a little bit crooked too. So that could just be the placement of the fan or what sort of airflow it generates because of the shape of the shroud. So I can't speak for any of that stuff. I can only interpret my data. So next let's go ahead and pull up on the screen the stock NC fan shroud sealed. And I want to point out on this one, it looks pretty much the same with a little bit of redistribution of a couple of numbers. And while we can attribute some of that to maybe my measuring inaccuracy, because using the anemometer, some of the positions, it would have the value jump up or down 0.3 to 0.5 even meters per second, and I would have to sit there and see if I could get it to stabilize. Some of the spots you'd put the anemometer there, 2 or 3 seconds, it was the same number the whole time. Good, that's solid data for me. But I say this because we can throw a little bit of uncertainty in there for that reason. However, let's go ahead and look at the stock NC versus the sealed up shroud. You'll notice that they're actually pretty close to the same. They both totaled out almost 260 for both of them. The minimums and maximums are very, very close. So this is to say that it is negligible difference, at least negligible measurable difference based on my testing, that sealing up your radiator versus not sealing up your radiator does, which is kind of mind-blowing, isn't it? My only thought here is that it's possible that the fan, while not being sealed up, is able to run at a higher RPM, let's say, and move more air, and even though it's losing some air flow through the radiator through the sides, maybe it's still able to pull the net amount through the radiator as the same as when you seal it up. So it's possible when you seal it up, you're putting more load on the fan and thus causing it to be able to pull less air, but then the net amount coming through the radiator being the same. But that's all my hypothesis is. Now let's show the really fun numbers. So the last one, the last fan that we checked out, which is from my setup, you'll see that it is dead center, because of course that's how I designed it. My fan's dead center, and all the numbers are much, much higher. So we see our maximum is now a 7.8 as opposed to the highest the other setups show was a 5.1, and even our lowest was a 1.4. Average-wise, we went up 1.8 meters per second across the board, and then of course you can see the totals. The total-wise, we went up, it seems like over 100 meters per second on the total thing. So easy enough to say that it pulled a lot of more air. So let's show the deltas, just for grins. So I went ahead and put together a delta comparison just so you can see where all of the gains and losses are. So there are a couple of spots that, per my measurements, they pull a little bit less. Like I said, the fan was biased on the stock setup to the passenger side. So what you'll notice right off the bat is there is a difference at that end, but on the opposite end we saw gains. Now I'm going to change over to a different type of gradient. This type of color gradient is showing the same gradient across all three of the fan setups we tested. Across all the three setups we tested. So what you'll notice is that almost no green is shown in the first two, and all the greens in the third one, because the values were so much higher that the gradient biased towards my fan setup. So I would like to address that I made a bit of maybe an experimental mistake today. I didn't take into account how much voltage drop there would be on that battery. So I've done other tests where we didn't have to worry about as much voltage drop off of the battery, but when I did the test setup for the stock fan at 12.7 volts, we should have done it at about 12.2-ish. But also at the same time, the test being conducted at 12.7 volts gives the advantage to the stock fan setup because it was run at a higher voltage. The way a power supply works is that it's able to maintain the voltage very constant because you set it as a constant voltage. So setting it at 12.7, the entire test was conducted at 12.7. Hooking up to a battery, you're going to see that voltage fluctuate, as well as, depending how long the test goes on, you could see the battery voltage drop off. And that's where I added on the power supply. So the power supply, it's not intended to charge the battery, but let's say assist the battery do as much as it possibly can to stay steady throughout the test. So while we were able to test the second setup between 12.3 and 12.5 volts, it sort of varied. Still, the advantage would be on the side of the stock fan as far as voltage goes. Voltage goes up, fan output goes up. But even so, the test showed we have overwhelming amounts of information, overwhelming amounts of data to show that it is, without question, not even beyond an inaccuracy of measurement like I've demonstrated as possible. It's far beyond that. So, result of the test, my aftermarket setup is going to hopefully do really well for a lot of people once I release it. And I'm looking forward to do so as well, because the market doesn't have one, and I'm really excited to come out with a new product. Well, thanks for watching. I appreciate you guys. Have a nice day.